Hey students, here is our second lesson of Unit 2. This is more inverses, and so now we're looking at what do we do when our function is not one-to-one? Our function is not one-to-one. How can we still find an inverse function? And so that is our problem that we're going to tackle today. Okay, here goes. Okay, so this is the second lesson in Unit 2. It's still dealing with inverse functions here. First question, and it says graph f of x equals x squared plus 3. So this is your x squared quadratic function just shifted up 3. I've already taken the liberties of graphing it. You can see I made a little table out here to the side, 0, 3, positive or negative 1 gives us 4, positive or negative 2 gives us 7. Is this one-to-one? Well, no, it doesn't pass the horizontal line test, so no, it is not. Does it have an inverse function? Well, no, it won't have an inverse function. It'll have an inverse relation. You know, if I reflect this over the y equals x, it won't be a function. It won't pass the vertical line test. So here's what we're going to do: restrict the domain of f of x so that f of x is one-to-one. So generally speaking, we want as much of the graph as we can get, as much of f of x as we can get without losing the fact that it's one-to-one. Alright, so I'm going to take just the right half. I'm going to start at the y-axis here and just take the right half. If I just basically get rid of this part over here, then it is one-to-one. I'm just taking this half, the right half of it. And so my domain, I'm going to start at 0. I am going to include 0, and I'm going to go to infinity here. And now that is one-to-one since I artificially restricted the domain. Okay? So now I can find the inverse. Find the inverse of f of x and graph it, give the domain and range of each function. So my original is x squared plus 3 with the restricted domain of 0 to infinity, and my range starts at 3 and goes to infinity. Okay? My range starts at 3 and goes up forever. Alright, so it should be that the inverse, the domain, will be from 3 to infinity. The range will be from 0 to infinity, just flipping my domain and range from the regular one. So let's see what we get here when I work it out algebraically. I'm going to say y equals x squared plus 3. I'm going to flip my x and y's. X equals y squared plus 3. I'm going to subtract 3 from both sides. X minus 3 equals y squared. Take square root of both sides. When I take the square root, I put positive or negative. So y equals the positive or negative square root of x minus 3. So I only want, since I'm restricting the domain to positives here, and I want the range, my output to be positives, I want the range here, my output to be positives, I'm going to disregard the negative here. That is not going to be part, this is part of restricting the domain, it means our range is going to be restricted here. And so it's only the positive root of x minus 3 here. Okay, if I'd restricted the domain the other way, if I'd gone from negative infinity to 0, then I would want the negative root of x minus 3 here. Alright, and if I graph that, if I put in, I can't put in 0, but the smallest number, here's my x, here's my y. The smallest number I can put in is 3. 3 gives me 0. If I put in 4, I get 1. If I put in 7, I get 2. So if I graph that, 3, 0, 4, 1, 7, 2, and there we go. All right. Okay, so bottom of the page, inverse of a function that is not one-to-one. If f of x is not one-to-one, restrict the domain so that f of x is one-to-one. So we will artificially restrict the domain if necessary. If f of x is not one-to-one. The restricted function will have an inverse function. Okay? If we artificially restrict it, then when we do the inverse, it will be a function because our original was one-to-one, even though we had to force it to do that. Okay, so let's look at another example. Actually, got two more here. For the following functions, graph f of x. If f of x is not one-to-one, restrict the domain, sketch f inverse of x, find the equation of the inverse function algebraically, state the domain and range of each function. Okay, so I'm going to make a table here for my original. If I put in 0, I'm going to have 8, If I put in 2, I'm going to have 2 times 2 is 4. If I put in 4, I'm going to have 0. If I put in 6, I'm going to have 4. And if I put in 8, I'm going to have 8. So my original function goes 0, 8, 2, 4, 0, 0, 2, 8, 8. So clearly, looking at the graph of this, clearly this is not one-to-one. It does not pass the horizontal line test. So I'm going to restrict the domain. And again, I'm going to take the right half of it. So I'm going to basically disregard this part, and I'm going to say the domain is going to go from 4 to infinity. My range is going to go from 0 to infinity. Alright, so down below I can go on and put in my domain from 0 to infinity, my range from 4 to infinity. Now I want to find the inverse of this one. So this, once I disregard the left half, this becomes just a line. Alright, this is just a line, and in fact basically it's the line represented by taking off my absolute values and making those parentheses. Y equals 2 times x minus 4 without absolute values, just parentheses. Okay, if I distribute the 2 here, I get 2x minus 8, and sure enough, if I continue this line down, it's going to cross at negative 8. Okay, so to find the inverse, I'm going to switch my x and y, add 8 to both sides, so I have 2, x plus 8 equals 2y, and then I'm going to multiply both sides times 1/2. Alright, my 1/2 times 2 will cancel. I'm going to distribute the 1/2 here, and I have 1/2 x plus 1/2 of 8 is 4, so there's my inverse. 1/2 x plus 4. 1/2 x plus 4. Let's graph that in red here. I'm going to start at 0, so let's make a table. For this one, the domain starts at 0, so I'm going to put in 0, 2, and 4 here. I think that should be good enough. If I put in 0, I get 4. If I put in 2, I get 5. If I put in 4, I get 6. So 0, 4, 2, 5, 4, 6. Remember, it starts at 0. It starts at the y-axis and does not go up any further than that. So this is going to start here, continue in that direction. Alright, you can see that my range, sure enough, is from 4 to infinity. My domain is from 0 to infinity. Alright, so that's what we'll do when we have absolute value. We'll just change it to a line, find the inverse of the line. Our last example is going to be a rational function. Okay, so this one, it would probably help if you graphed this one, but what you'll see, I can, if I put the denominator equal to 0 to find out where the asymptotes are, I get x squared equals 1, and if I take square root of both sides, positive or negative, I get positive or negative 1 here. So I have an asymptote at positive 1, I have an asymptote at negative 1. If I put in 0 for a point, I get 0. And what you'll see graphing this is that this middle part looks like a very skinny little parabola that just follows the asymptotes there. For my horizontal asymptote, again, I look at this 2x squared over x squared. If the x squareds cancel, I get 2. My horizontal asymptote is y equals 2, which is just this horizontal line going through 2. And so I mean, I could get a value here, but you know, again, you can look at this from the graph, but basically we have a branch up here, and then I've got another branch over here. Okay? So this is my graph. Clearly does not pass the horizontal line test. Okay? It doesn't pass this parabola part, does not work, and then this upper part does not work either. So I'm going to restrict the domain starting at the y-axis, because if I only look at the right side of the graph, it passes the horizontal line test fine. And so I'm going to say from 0 to 1, not including the 1, and then from 1 to infinity. All right? The range goes from negative infinity up to 0, including the 0, and then it skips up to 2, and then we have from 2 to infinity, not including the 2 because I have an asymptote at 2. Okay? So I'm going to reverse those for my inverse. This will be negative infinity to 0 with a bracket. This will be 2 with a parentheses to infinity, parentheses. My range will be 0 to 1, then 1 to infinity. Alright, so let's see if we can work this one out. So I'm going to write this as y equals 2x squared over x squared minus 1. Okay, I'm going to switch my x's and y's. X equals 2y squared over y squared minus 1. First step, again, let's get rid of that fraction. I'm going to multiply both sides times y squared minus 1. On the right it cancels. On the left I'm going to distribute x y squared minus x. I'm going to get the y squares on the same side. So I'm going to leave the xy squared where it is. I'm going to subtract 2y squared. And I'm going to go on and move that x to the right by adding it. So this will be a positive x. Now I'm going to factor y squared out. This will leave me x minus 2. If you're not sure about that, go on and distribute the y squared and you'll see that that's what we get. And now last step, I'm going to divide both sides by x minus 2. Well, not quite the last step, I guess. It'll cancel here because I still have to take the square root. X over x minus 2. I'm going to take the square root. In general, I would put plus or minus here. But in this case, I'm only looking at the positive root because of I only took the right part of the graph. In fact, I should go back up here while I'm thinking about it and scratch out. This is not going to be part of what we're considering because of our restriction. Okay. All right. So I've got y is equal to the square root of x over x minus 2. Pretty clearly, x cannot equal 2. So that's my vertical asymptote. And if I notice that x over x, that's going to give me 1. So the y value cannot equal 1. So I have a horizontal asymptote there. All right. If I make a table here, I'm putting in values from negative infinity to 0. So I can put in 0 here and I get 0. Goes to 0, 0. All right. If I cannot put like 1 in. If I put in 1, I'm going to get a negative number. So that doesn't work. Anything bigger than 0, in fact, will give me a negative number, and that's not going to be any good. But I can put in numbers smaller than 0. If I put a negative number in here, then I have a negative divided by negative will be a positive. But what this thing's going to do is go this way. Okay, that's that part of it. Now I'm going to put in values larger than 2. If I put in values larger than 2, I do get positive answers, and they're going to be up in this area. And again, you can graph this on your calculator, go to the y equals screen, square root. To get to the, let me just show you real quick. So I'm going to go to the y equals screen. I'm going to clear out anything that's in here. And I'm going to do the square root. Now I'm going to hit math left arrow and it takes me to the frac screen. I'm going to press enter and now I can put in a fraction. X is right below mode. X minus 2 is my denominator. And now if I graph this, oops, I'll have to change my window. Hang on just a second, it's got to wait to graph. Zoom 6 will always give me the standard window. So you can see this part of it over here. And this, it kind of cuts it off, but it is following that asymptote going up. All right, that is that.